guys, good evening to all of you and welcome back to the sessions. A wonderful evening here it is, and today we are going to study about one more chapter for your class 10th board examinations in this Sprint X series. So welcome back to the sessions all of you, and it's a very pleasurable thing to teach you all guys, because the kind of response from which I am getting from you all guys through the comment box and through your responses through mails and my WhatsApp messages, it's really outstanding and it's really very nice and motivating. So because of that motivation, I am able to form such kind of videos for you all for your class 10th board examinations, and I am really happy and delightful for that. So without wasting much time, today we will be dealing with one of the next chapter, that is circles. And circles will be dealt right now, and thereafter in the next session surface area volume would be dealt. So I guess you would have understood all the questions and concepts which I have taken in my previous session, but still if you do have any doubt, you can simply put your comment in the comment box, and I am even responding to that. I am getting multiple responses even in the comment box. All of you guys are pretty excited and happy to see this Sprint X session. And knowing this, I am also very excited and motivated that you guys are liking it so much. So with this, let us start our today's session. In today's session, we are going to deal with circles question. And the first question goes right now here. This is the first question. Let's start solving this first question. In the figure, a triangle ABC is drawn to circumscribe a circle of radius 4 cm. Okay, radius is given 4 cm, such that the segments BD and DC are of length 8 cm and 6 cm respectively. Find the sides AB and AC. Okay, that's nice. Now this question is, you would have seen this question, although I would not say that it is an easy question, but yes, it is an important question. You would have seen this question at multiple places in your textbooks also, but I have taken these questions just because of this thought that this is an important question. Why? Because multiple times board has asked the very same question, and even I'll tell you that many a times it has happened that board has not even changed this value. It is 8 cm and 6 cm. Multiple times it has been asked in the board examinations. So that is why I have taken this question, just to remind you that this question is very important. So let us solve this question. How to solve this? Although it's an easy one, not a tough one. BD is written as 8 and DC is 6. So this is 8 and this is 6. Now you all know that if this is BD is 8, then surely let us name is BDE and this as F. So BF will be also 8. Why? Because tangent from an external point to a circle is always of equal length. So this 8 and this is 8. This is 6, then this is also 6. Now we do not know this length of AF and AE. So that is why I'll assume it as X and X. Now it is said that radius of this circle is 4 cm. So I'll just draw a radius, that is 4. From here also I can draw a radius, that will be 4, and from here also I can draw a radius, that will be a 4 cm. Now I have drawn 3 radius. Now just pay attention how we will solve this question. We will solve this question. I will join this now, and I will join this also, and I will join this also. So here this triangle ABC has been divided into 3 triangles: OAB, OBC and OCA. Okay, in 3 triangles. Now what I will do, my course of action would be, I will write area triangle ABC. Area triangle ABC can be written as area triangle OAB plus area triangle OBC plus area triangle OCA. Did you understand this? ABC can be written as OAB, OBC and OCA. All 3 triangles, sum of all 3 triangles is equal to the sum of triangle ABC. Now for triangle ABC, you know, we have the sides length. Okay, we have the length of the sides. Now if we have the length of the sides, we will be applying Pythagoras theorem here. Okay, and sorry, not Pythagoras, I'm sorry, we will be applying Heron's formula here. And let me tell you, when applying Heron's formula, it will be not an easy task. So that is why we'll have to take some precaution, but for these 3 triangles it will be easy. I'll show you how. First of all, let us put a Heron's formula here. So for area triangle ABC, first of all get the semi-perimeter. So I am writing S semi-perimeter, that is 8 plus x. See here, 8 2 times, x is also 2 times and 6 is also 2 times. So I am directly writing 8 plus 6 plus x, that is all 2 times. Isn't it? 8 2 times, 6 2 times and x is 2 times. This is perimeter divided by 2. That is semi-perimeter, S, value of S. Now 2 and 2 will be cancelled. 8 plus x is 14. So we have 14 plus x as our semi-perimeter. Now the formula lies like this. Area is equal to root under S into S minus A into S minus B into S minus C. Now once we have this formula, what we will be doing? We will be simply putting the values. So let me put the value is equal to root under S. S is 14 plus x into 14 plus x minus A. So what is A? So if you take this side as A, 8 plus x would be the one side. Let me write it down. This side is 8 plus x. Are you able to see it? 8 plus x. Let me change the color. This better would be this color, blue. Okay. Now 8 plus x, this would be 14. This is 8 plus x and this would be 6 plus x. So this is how the sides will work. This is how the length of sides will be. So first side 8 plus x, second side 14 and third side 6 plus x. And we will be subtracting these things from this quantity. So let me subtract 14 plus x minus A. A means 8 and minus x, okay. This is minus 8 minus x because I am subtracting this whole term. So it will get a negative sign for both the terms. So 14 plus x minus 8 minus x. This is S minus A. Now in the similar fashion, S minus B would be there. So I am just writing S minus B directly, 14 plus x, and if you do the minus, it will be minus 14, and thereafter for the last one 6 plus x. So I'm writing directly, if you subtract 14 plus x minus 6 plus x. So 14 minus 6 would be 8 and x minus x would be cancelled. Just like here, 14 minus 8, here it is 8, here it is 6. So 14 minus 6 is 8. So I'm writing here 8 and x minus x is cancelled. So that will be the final answer. That will be the term. I guess you would have understood this. Guys, did you understand this? Please pay attention. If you are not understanding, you can write down for this term, you can write down 14 plus x minus 6 minus x, like here. You will be getting this term. Okay. Now let us solve this question. So root under 14 plus x. Now 14 minus 8 is 6. 14 plus x minus 14. 14 and 14 getting cancelled. X into 8. Now we have this term. Okay, so I guess we are clear. This is the area of triangle ABC. I am writing here area triangle ABC. This is ABC. Now pay attention. What we had to do, area triangle ABC equal to OAB plus OBC plus OCA. For that, pay attention here. Are you able to see that this will be a 90 degree? Why I am telling this? Because it is a radius and this is a tangent. So radius is always perpendicular to tangent. Now area of triangle OAB can be written as half into base. This is base AB. Half into base AB into height OF. Isn't it? So half into 8 plus x. Base is 8 plus x. Into height is 4. So half into base into height. Half into 8 plus x into 4. Now similarly, half into 14 into 4. Half into base into height. Height is 4 again. And half into base into height. Half into 6 plus x into 4. So everywhere height would be same, every time base will be changing. So I am just writing down for all three of them. Let us see. So I am writing area triangle OAB plus OBC plus OCA. That will be is equal to, I am writing here, half into base would be, in the first case it was 8 plus x into 4 plus half into base was this time 14 into 4 because base was 14, and in the third case half into base was 6 plus x and into 4, and from all of the 3 I'll take half common and I'll take 4 common, and remaining would be 8 plus x plus 14 plus 6 plus x, isn't it? Now pay attention that this half will be cancelled, so it will be 2, and here 8 plus 6 is 14 and 14 plus 14 is 28, and x plus x is 2x, so it will be 28 plus 2x, and now taking 2 common, so it will become 4, and here 2 common, 2 2s are 4, and 28 when I'll be taking 2 common, so it will be 14 and it will be x, so this is 14 plus x. Now this is the final area which we have got for area sum of 3 areas of this triangle. Now once we have got this, I'll make this equal to the first value which I had got here. Now just to make both of them equal, let us see this is the value 14 plus x 6, so it will be 8 6 are 48, 48x into 14 plus x. So I'm writing here, this implies root under 48x into 14 plus x is equal to 4 into 14 plus x. Now you all must be knowing how to solve this kind of question, because here there is one side root and one side not root, so you will be just doing squaring both sides so that this square root gets over. So I am just writing here squaring. So once squaring, I'll be getting like 48x into 14 plus x is equal to, here I'll be getting 4 square into 14 plus x whole square, isn't it? I have squared both of them. So now what I'll be doing, 14 plus x will be cancelled by this square only one times, and this, pay attention, 4 square, do you know the value of 4 square? It is 16. 16 will be cancelling this 48 in 3 times. So we have 3 into x, that is 3x into nothing, and is equal to, I am writing here only 14 plus x is remaining. 14 plus x is remaining. So what we have left, sending this x to this side, it will become 2x is equal to 14. That is nothing but x is equal to 7. Okay, x will be equal to 7. Now guys, pay attention, we have got x equal to 7. What we were asked in this question, pay attention, find the sides AB and AC. So we have got our AB, isn't it? 7, 8 plus 7 is 15 and 7 plus 6 is 13. So we have got 15 and 13 as AB and AC, the sides of the triangle. Okay, did you understand this? Now let me tell you, many of the students even they were telling that, sir, please be a little slow, give us some time to write down. See guys, what I am telling you, these videos will be there in the YouTube. Okay, so you need not to worry about this. Say for example, if you feel that you are not able to note it down, what you can do, you can just replay it, and thereafter you'll be getting multiple times. You can even pause it and you can see multiple times. You will get a better picture of this. I am taking these sessions fastly only just to save your time, because there might be many students who might be not requiring that much time to write it down or something like that. So they should not feel that, sir, it's getting too long, isn't it? So I guess I'm clear with my point. I'll just write down the final answer, that is AB. AB is equal to 8 plus 7, that is 15, and AC is equal to AC is equal to 6 plus 7, that is equal to 13. So we have got both the values AB and AC of this triangle, sides AB and AC. I guess I'm clear. Now moving to the next question without wasting much time, here goes the next question. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. I guess you would have seen this question also in the textbook or in some RS Agarwal or in some RD Sharma. But again, this question is very important, and this takes a good analytics to solve this question. Let us see how to solve this question. So I'll just draw a diagram, rough hand. We have to prove that opposite sides of a quadrilateral circumscribing a circle. Okay. Now this is also very important. Students don't understand that, sir, circle is outside the quadrilateral or inside the quadrilateral. So for this, I'll tell you. See here, language. Quadrilateral circumscribing a circle. Circumscribing always means outside. Always remember, circum means outside, inscribing means inside. So quadrilateral circumscribing means quadrilateral will be outside and circle will be inside, because it is said quadrilateral circumscribing a circle. So let us make a circle first. I'll use some shapes. This looks good, isn't it? Yes, this looks good. Now, yes. So, and I'll draw a quadrilateral. Oh, guys, don't comment upon my drawing because I'm a very good painter, and if I'm not able to paint good, then also say that I have made a good drawing. Okay, that will motivate me. Okay, moving on to next. So this is ABCD, and this is the center. Now we have to prove that opposite sides of quadrilateral circumscribe subtend supplementary angles at the center. Now let me tell you what I'll do. I'll join this. I'll join this also. I'll join this also, and I'll join this also. Okay, let's make a strong solid line here. चलो देखते हैं. Yes. Now what? Now I don't know what to do. Okay, I know that. Let us do one thing. क्या करूँ? बता दूँ? देखो बताता हूँ. Okay. Draw this line and draw this line. Okay. See, drawing is getting a bit screwed up, but don't get worried about that. Okay. Now this is 90 degree. This is 90 degree. You would have proved this question earlier in your circles chapter, that prove that the length of tangent is equal from the external point, isn't it? So I am again using that theorem only. Say for example, this is P, this will be Q, this will be R, and this will be S. So AP will be equal to AS. 90 degree equal, and AO, this AO will be AO equal, means common. So now what I am trying to tell, that these two triangles will be congruent, isn't it? You know that these two triangles will be congruent. I'm just giving you a glimpse. So I won't be using that. I will be directly applying that concept here, that from an external point tangents are of equal length and they subtend equal angle at the center. So that makes the base of my word that I want to write here. I want to write here that this angle would be x, then if this angle is x, then this angle will be also x. Both the angles are same. And using, now let me tell you, I am skipping the step here because I'm a teacher. I have that what you can say, window, but you don't skip this step. Otherwise you lose your marks in your board exams. So write the step that why you have written both the angles equal. Now using the same concept, you can write similarly, if this angle will be y, then this angle will also be y. Why I am telling this? Sorry, not this angle. I'm sorry. This angle. Draw a perpendicular here also. So this angle will also be y. Okay. Now again similarly, here also put a perpendicular. If this angle is z, then this angle will also be z. And if this angle is w, then this angle will also be w. Because from an external point, tangent always subtend equal angle at the center. Now you would have got these all angles. Here we have 2x, 2y, 2z and 2w. So what I'll do, I'll simply add all of them. If you add all of them, what you will be getting? I'm writing 2 times w plus 2 times x plus 2 times y plus 2 times z. Just tell me what it will be equal to. It will be equal to 360 degree. That's nice. Taking 2 common, we will be getting w plus x plus y plus z is equal to 360, and needless to say that it will be w plus x plus y plus z, that is equal to 180. Now I'll tell you what this means. See in the figure what I have written and what is there in the figure. In the figure it is x plus y, angle made by this tangent AB at the center is x plus y, and here it is w plus z. So if I add x plus y, yes, x plus y plus w plus z, this means angle AOB plus angle COD, isn't it? X plus y plus w plus z is COD plus AOB. And pay attention, this we had to prove that opposite sides of a quadrilateral circumscribing subtend supplementary angle, isn't it? Supplementary means 180 degree, and that we have proved. So I'll just write it down here. The last line, this implies angle AOB plus angle COD is equal to 180 degree, and thereafter I'll write similarly angle AOD plus angle BOC is also equal to 180 degree, and thereafter the golden words, the beautiful words, hence proved. This is the most beautiful word, isn't it? Because when we do this, it gives us a lot of pleasure. Now, hence proved. So I guess you would have got this. AOB plus COD and then AOD plus BOC. Both of them are proved, and we have got what we had to prove. So these proof questions are very important. I know these questions are the pain point for you guys. You must be feeling a lot of trouble, so that is why I have taken most of the proof questions here in this session. So let's move on to our next question. I guess you would have understood this. Prove that the tangents drawn at the midpoint of an arc to a circle is parallel to the chord joining the end points of the chord. You would have seen this question many times, again I am telling. But let me tell you, most of the guys do not know how to prove this question, because this is a kind of, means everyone knows that yes, it will be parallel. Okay, everyone knows that. But no one knows how to write this. So I'll tell you the steps how to write this question. Let us solve this question first. This one. So this is a triangle. This is a circle. Yes. What we have to do, prove that the tangent drawn at the midpoint of an arc. So first of all, take an arc. So I am taking this point and I am taking this point. Okay. Let us name this AB. So this AB is nothing but an arc. Now take a midpoint of this arc. Let us say this C. Okay. Now I have taken this. Prove that tangent drawn at the midpoint. So here you have to draw a tangent. Assume this as a straight line, although it has tried a lot to be a straight line, but it is still not up to that mark. But yes, assume that this is a straight line. Its aspiration, his aspiration is to be a straight line. Now, this is a midpoint. Arc of a circle is parallel to the chord joining the midpoint. Means this line will be parallel to this line, this AB. We have to prove this. Now, this is the question. Now, what we will do? Just join the circle. See, I am skipping the step given and to prove. I guess you will write that. Given is this things, and what we have to prove, that we have to prove this line PQ. Line PQ is parallel to AB. Isn't it looking parallel? Yes, assume it is parallel. In maths, this is the best thing. We can assume everything. Okay. So what you need to do, steps of construction. I am writing the first step of construction, that join the point OA and join the point OC. Okay, now we have got, and then join the point OB. So step of construction you have written. Now the first thing which you will write, which will make the whole question proved, is like this, that here you will write equal arcs. This is the most important line, and you need to write it down in your paper also. It will get you marks. Equal arcs subtend equal angle at the center. Equal angle at the center. Now you all must be knowing this, but this is the line which you have to put it there. This is the reason. Now once you have done this, I'll just make you prove that how this is gonna prove. So this angle, if I assume this theta, then this angle will also be theta. I have written this. Now the steps of proving. So what I will do one thing. What? I don't know. Let's see what we'll do. So let us mark this. Arey yaar, kyun pareshan kar rahe ho? Let us mark this point AD. Okay. Now, are you able to see that this OA and OB will be equal because it is radius? This angle is equal because it is already proven, theta. And this OD and OD will be common. So what I mean to say, again I am skipping step because I am a teacher. Just joking यार. स्टेप्स सिर्फ इसलिए मिस कर लेता हूं क्योंकि अब थोड़ा मतलब टीचर वाली वो फीलिंग आ जाती है. बच्चा था तो मैं भी नहीं कर पाता था. टीचर बहुत मारता था मेरे को. बदमाश टीचर. नहीं, बदमाश नहीं था. टीचर्स आर ऑलवेज गुड. यस, व्हाट आई वाज टेलिंग, आई विल राइट हियर ट्रायंगल AOD. Triangle AOD is congruent to triangle. Which triangle? Just tell me. BOD. And reason being side angle side. Reason being side angle side. Side equal, angle equal, and this side equal. Now side angle side, both the triangles are congruent. So this makes me say this. This implies, I am writing angle ADO. This angle ADO. Pay attention, guys. ADO is equal to angle BDO. And if both the angles are equal, this will be nothing but 90 degree. Do you know that? This will be nothing but 90 degree. Now, question proved. Question is proved. How this is proved? Because if this is 90 degree, guys, if this is 90 degree, surely you know that this angle line means radius to the tangent, it is always 90 degree. So you will write just that line, that we know that radius is always perpendicular to the tangent. So that is why this point C, this is C, OCQ, angle OCQ. So you will write here also angle OCQ is equal to 90 degree. Since both the angles are equal, so the corresponding angles are equal. So I'll write, since corresponding angles are equal, hence AB is parallel to PQ. Proved. I'm writing here. I'm writing here, since corresponding angles are equal, therefore AB is parallel to PQ. And again the golden words, Harshpriyam, no, hence proved. Now AB is parallel to PQ. So again this question will be proved in this way, and this is the most accurate way, and this is the most least steps consumed method. Means it will consume your least time. You do not need to do a lot many things, because books have a lot more method, so you can prove this in this shorter steps. So I guess it must be clear to you all that how you will prove this question. If you still feel any problem, please rewind the video and you will be getting a more better picture of this. Now let's move on to our next question. Here goes the next question. In a figure, tangents PQ and PR are drawn from an external point PQ and PR. Point P to a circle with center O given, such that angle RPQ is 30 degree. Okay. A chord RS is drawn. This is RS. RS is drawn parallel to tangent PQ. Okay, they are parallel. Sorry, they are parallel. So I'll just write it down. This line and this line is parallel. So now once they are parallel, a chord RS parallel to tangent. Find angle RQS. Okay, that's nice. Let us see this question. How this question is going to be solved. Now what? Now let us solve this question. So how this will be solved, I don't know, by the way, but I'll make it out somehow. So if this is, what? Okay, let's see how this question is going to be solved. We have to find this angle. Okay, we have to find this angle. Now this is 30 degree, it is given. Now if this is 30 degree is given and they are parallel, so what I will do, that if they are parallel, this angle and this angle will be equal. That is nice. Okay. Apart from that, do you know that RP and PQ will be equal? RP and PQ will be equal because they are from an external point equal length of tangents. So if they are equal, this angle and this angle will be equal. So if I say it x, then x and x will be equal. So I'll just write it down, x plus 30 is equal to 180 degree, and solving them, x will be nothing but 75 degree. Now if this x is 75 degree, guys, then surely this angle is also going to be 75 degree. Why I am telling this? Because RS and PQ are parallel. Okay, so now what we will do, that we will simply see here, we have got the value of x we have got the value of x as equal to 75 degree. Now you all must be knowing that how alternate segment theorem. You all must be knowing alternate segment theorem, and using that alternate segment theorem, this is a tangent. Okay, this is a tangent. Now if this PQ is a chord, and if this RQ is a chord, and if this RQ is making an angle with the tangent, that is 75 degree, then this chord RQ will subtend the same angle at the remaining portion of the circle. This is what is called as alternate segment theorem. Guys, again pay attention, I will make you understand this alternate segment theorem. Alternate segment theorem, what I mean to say, important है इसलिए ध्यान दो. This is tangent. Now from this contact point, if a chord is drawn, from a contact point if a chord is drawn, then angle made by this chord and this tangent, say for example x, will be same that the angle made by this chord over any portion of the circle, that x. They will be always same, and this is called alternate segment theorem. Means the angle made by this line with the tangent, there are two angles, one is minor angle and one is major angle. See here, this is major angle. So minor angle is equal to the angle made by this chord in the major segment. See here, this is major segment. So this angle, it will be equal to x. So using this same concept, I have made that this is 75 degree, then surely this will also be 75 degree. Now pay attention. In the very similar fashion, let us see that here we have got almost everything. This is 75 degree and this is 75 degree and this is 30 degree. Now 75, yes. Now pay attention. If I talk, this is 75 S. So I have got S, I have got P, I have got R also, because R is 75 plus 75, 150. So I have got all the angles. So what I will be doing, simply I will be writing that what we have got and what we need to find. So pay attention, I'll write angle P plus Q plus R plus S. All of them should be equal to 360 degree because they are the angle of a quadrilateral. Now write the value of P, that is 30 degree, plus for Q, see in Q you have two angles, 75 degree and angle RQS, which we have to find. So I'll write angle RQS plus 75 degree, isn't it? Plus for angle R, we have again two angles, that is 75 degree and 75 degree. So I will write for R 150 degree, plus for angle S we already have, that is 75 degree. So I'll write again 75 degree equals to 360 degree. Okay. So guys, I guess you would have understood this. 75, 150, 300, 330, 330. So RQS, what we have got here, RQS is angle RQS is equal to 360 degree minus 330 degree, and we have got our value, that is 30 degree. So did you understand this problem? It was a good question. Let me tell you again. This angle 30 degree. Okay. Now both the sides are equal, so both the angles will be equal. I have assumed them x, so they will be solving them. They will be we'll be getting the value 75, 75, and this is 30. So now if this is 75, then surely this will also be 75. This will now this will, if this is 75, then this will also be 75. Why I am telling this? Because of alternate segment theorem, x, then this will also be x. So alternate segment theorem, if this is 75, then this will be also 75. Now this is 75, this is 75, and if this is 75, then this angle SRQ will also be 75. Why I am telling this? Because of alternate interior angles. So this is 75, 75. So I guess we have got all the angles except this angle RQS. So we have to find this RQS. So I just use the property of all angles, sum of all angles of a quadrilateral is 360 degree. So adding all of them, we got 360 degree. So I have written 360, and then putting all the value, we got this value of RQS. So I guess this must be clear to you. It was a very good question and a very puzzling question. So here what we have got the answer. Now moving on to the next question. And the next question goes like this. In the given figure, two equal circles with center O and O dash touch each other at X. This is X. O dash at A. O dash at A. Okay. AC is tangent to the circle with center O. And this is the tangent. Okay. O dash D is perpendicular to AC. Okay. Find the value of DO dash upon CO. Again, a very easy question. Let me tell you how. Let us see how to solve this question. Guys, pay attention. Both the circles are equal. They are of equal length. So if I assume this radius r, then this will also be radius r, this will also be radius r. Okay. Now if this is tangent and this is circle, if this is tangent and this is circle, so this will be 90 degree, isn't it? This will be 90 degree, and similarly here also it will be 90 degree. Okay, so both of them are 90 degree. Now, so they will be kind of parallel, isn't it? They will be kind of parallel. Now, if both of them are parallel, I'll write it down. Triangle AO dash D, AO dash D, AO dash D and AOC is similar to triangle AOC. AO dash D will be similar to AOD. AO dash D will be similar to AOC. Why? Because both of them is parallel. Now, what you need to do, you have to find the value of O dash D upon OC. Means they are similar, so I can write down the ratio. So I'll write down AO dash upon AO is equal to O dash D upon OC, isn't it? Now, once you have got this, you have got the value. AO dash is nothing but R divided by AO, 1R, 2R and 3R. So it is 3R. That is O dash D upon OC. This we have to get, and here we have got the value, that is 1 upon 3. I guess you would have understood this. An easy question again, but yes, let me tell you an important one. Because why I am telling this is important, because here in this question, the question has applied the concepts of circles and triangles both in the same question. So it's a multiple concept question, so that is why it is important. Now, if you have understood this, moving on to our next question. Here goes the next question, guys. In the given figure, O is the center of a circle of radius 5 centimeter. O 5 centimeter radius. Okay. T is a point such that OT is equal to 13. That's nice. And OT intersects circle at E. Okay, circle at E. Okay. AB is a tangent to the circle. AB is tangent to the circle. Find the tangent to the circle at E. Find the length of AB. Find the length of AB, this length, where TP and TQ are two tangents to the circle. TP and TQ are the two tangents. Now, this is the question. Now, let us write what all are the given values which is given here. So, this is 5. This will be 5 and this will also be 5. Remaining would be 8, isn't it? Because it is complete 13 centimeter. Now, pay attention. This is 90 degree. Why I am telling this 90 degree? Because this is radius perpendicular to tangent. This is 13 degree, this is 5. So you will apply Pythagoras theorem, and by applying Pythagoras theorem you will get the value 12. Just apply a Pythagoras theorem and you will get the value, isn't it? So PT will be equal to OT square minus OP square. I am just writing here PT square is equal to OT square minus OP square. That is 13 square minus 5 square, and hence this is 12 square. Now we have got this value also. Now what else do we need? Find the length of AB. We need the length of AB. Now everyone, please pay attention. Is there any method with which we can get the value? I guess yes. And it's again a very good question. I'll tell you a very easy method, but thinking that method is a kind of typical one. Why? Because again here in this circle question, there are two concepts included. Triangles concept and circles concept. So everyone just pay attention. Do you know that this angle would be 90 degree? Why I am telling this? Because this is radius and it is tangent. So this will also be 90 degree. Now I am saying that look for the triangle ATE. Triangle ATE, writing here. A, T and E. In ATE, A is the first angle, T is the second angle and 90 degree is the third angle. Then pay attention to OTP. This triangle will be similar to triangle OT and P. Why I am telling this? Because O first angle, T is the second angle, again common in both of them. T and T, they are equal. And P here is 90 degree, E here is 90 degree. So they are also same. So using angle similarity, we can say that both the triangles are similar. ATE and OTP. Now see here. ATE and OTP. So if I write down, I will be writing down AT divided by OT is equal to TE divided by TP is equal to AE divided by OP, isn't it? Now see which values you have. So, and yes, one thing, no, not one thing more important. AT we do not know. Okay, we do not know. OT we know. Okay, so AT divided by OT. OT is the value of 13, has a value 13 equal to TE. Do we know TE? Yes, we know TE equal to 8 divided by TP. TP, yes, we know TP also, that is 12. And I guess thereafter nothing is required. AE. So write it down, AE, because we do not know AE, divided by OP. OP, yes, we know OP also, that is 5. So guys, we here it was said that find the length of the tangents TQ and TP. So very easy, sorry, not that. Find the length of AB. So AB, if we will get the value of AE, we will just multiply it by 2 and we will get the value. So it's again easy, because from here you will be getting the value of AE, isn't it? So just cross multiply them and you will be getting the value. Writing down here, this is AE, so AE will be equal to, I am writing down, 8 5s are 40 divided by 12, cancelling it by 4, 3 times 4, and it will be 10 times. So this will be nothing but 10 by 3. Now if you have got AE equal to 10 by 3, you will be getting the value of AB. How? So I am writing here, this implies AB is equal to 20 by 3. 2 times 10 by 3, isn't it? And you have got the value of AB. So in this method, you can get the value of AB and you can get the value of all the other parameters, isn't it? So it's clear. Now moving to the next, this is AB. Yes, only this much has to be solved, length of AB. Okay, so I guess this must be clear to you all. Now if this is clear, moving on to next question. And let me tell you, this is an easy one. This is not a tough one, but yes, just thinking that which two triangles has to be made similar was an important one. So now if you have done this, now you are good to go. Moving on to next. Here goes the next question. Yes, and I guess the last question probably for today's session. I don't know, by the way, whether it's last or first. So prove that the length of tangents drawn from an external point to a circle are equal. We have to prove this. Now I guess this is an easy one, very easy one here. I'll just make it rough diagram. This question I have taken only with one view so that I can make you understand that this question is very important from your board perspective. Yes, so what I was telling ki this is going to, yes, this is a circle. So this is a circle and it has a center. So we have to prove that length of tangents drawn from external point will be of equal length. So draw a tangent and draw this tangent. Just trying to touch. Now this is P, this is O. From here draw a perpendicular. From here draw a perpendicular. Both the perpendiculars will be radius itself. Now join this point. Join this point. Now once you have done this, I guess answer is clear. How? Say this OA and OB. So OA and OB will be equal because they are radius. 90 degree would be equal because they are 90 degree, and OP is common, and that is why right angle, hypotenuse and side. So triangle OAP, I am writing here triangle OAP is congruent to triangle, which triangle? OAP, OBP. Reason being RHS, isn't it? I have not tabulated the whole steps. Let me tell you that you need to write given to prove, then the steps of construction. First step being angle A equal to angle B 90 degree, OA equal to OB radius, and then OP equal to OP common. These 3 steps. Then writing this part that they are congruent, and thereafter writing this implies PA is equal to PB, that is because of CPCT. Let me tell you, in all the proof questions, writing reasons is very important, because if you have written a step and you have not written the reason that why you have written such step, that step has no marks. So let me tell you, writing the reason is very important. So please write the reasons always. Now, and this is proved. And let me tell you, this is an important question, guys. This is very important. So don't leave this question. Just I have taken this, it's a very easy one, but still I have taken this only to make you remind that don't leave this question. Now moving to the next. Okay. So this was all for today's session. Again, a very wonderful session with you all, guys. I really feel very elated and excited and motivated when I come to you guys, when I do such kind of videos for you all, and it's always awesome. So thank you very much for coming to the sessions, and do comment in the comment box whatever you feel about the video, and if you have any query, I'll keep on responding to you. And with this, I'll be saying a very goodbye to all of you. See you guys in the next session. Till then, bye bye and take care.